Hello and welcome to helpyourmath.com. In this video, we're going to look at examples of complex fractions when the numerator and or the denominator isn't written as one single term. Before we look at the examples, first of all, what does it mean for the numerator to be one term? And then why do we care that it's one term? Well, what it means for the numerator to be one term is if we have a numerator, so just focusing on the numerator for a second, remember these are complex fractions, so this is fractions within fractions. If we see something like a plus b over c, this is one term. But if we see something like a over b plus c over d, this is how many terms? This is two terms. And what we would want to do is we would want to rewrite the numerator so that it's just one term, so that it ends up looking something like this, where we just have one single denominator and then whatever going on in the numerator. Okay, why do we want there to be just one term? Well, because when we're dealing with complex fractions, remember what we're talking about. We're talking about something of the form a over b over c over d. And what we want to do is we want to be able to use the division property to first rewrite it using the little division sign, hence a over b divided by c over d, because ultimately what we want to do is be able to divide by the reciprocal, multiply by the reciprocal, and be able to use this a over b times d over c, where we could finally look to see if we could simplify this monster. Now, going back to why is this important? Well, because if we have something like this, we can't take the reciprocal of that. Let's think about 1/2 plus 1/2, okay? So putting this together, since we can actually add this, 1/2 plus 1/2 is 1 whole, and the reciprocal of 1 is 1. If you took the reciprocal of these things separately, then you would have 2 over 1 plus 2 over 1, which is equal to 4. Those are not the same thing. So you can't take the reciprocal of individual terms and keep the value the same. That doesn't work. This is not how math works. But what we could do is we could find that, well, we already have a common denominator. We'd have 1 plus 1 over 2, and we'd be able to take the reciprocal of 1 plus 1 over 2. The reciprocal would be 2 over 1 plus 1, which is 1. And this is okay. This is good, right? Because that still equals 1. So that's why it's important that we rewrite the numerator as one single term and the denominator as one single term before we think about doing anything of this nature. Got it? Okay, let's find out. We want to simplify as much as possible. And complex fractions are scary. It's taking the scariest type of number and the scariest operation and putting it all together. I get that. It's scary. Separate it as much as you can. So we're going to first focus on the numerator. Denominator ceases to exist for the next few minutes. If we look at just the numerator, we have x over 2 plus 1 over 2. We want to identify a common denominator, which luckily is given for us because they both have a denominator of 2. Rewrite this as one single term, x plus 1 over 2. Okay, so now this is one term, right? This is one term, this is good, this is what we want. This was how many terms? This was 2 terms, that was bad. We needed to combine them so that we could have just one term. Okay, now we're ready for the denominator. In the denominator, we have x squared over 3 plus x over 3. The good news for us is that we already have a common denominator. We can write this as the single term x squared plus x divided by 3. Now we can put it all back together, and just for a minute, bear with me with the really scary complex fraction, but we're immediately going to rewrite it, don't worry. So we have x plus 1 over 2 over x squared plus x over 3. Now that it's written as single term over single term, now we can use the division, or rewrite it with the little division symbol. So we can say x plus 1 divided by 2, little division symbol, x squared plus x divided by 3. Now we can say, wait, I know that division is the same as multiplication if I multiply by the reciprocal of the divisor. So now we can rewrite this as x plus 1 divided by 2 times the reciprocal of the divisor, 3 over x squared plus x. Now we're ready to see if any of the 4 corners can be simplified. So x plus 1, nope, can't be factored. Sorry, factored, not simplified, factored. 2, no. 3, no. How about x squared plus x? Yeah, we have a GCF there. It's going to be x, leaving behind an x plus 1. And now look, we have a common factor in the denominator and the numerator. And our final quotient will be 3 over 2x. And that would be it for this example. Okay. In our next example, let's see what we have. The numerator I see has 3 terms, so we need to get it down to one term. So we're going to focus only on the numerator right now. In the numerator, we have 2 plus 5 over a minus 3 over a squared. If we're going to get this to one term, then we need to be able to combine these, finding the common denominator. So the common denominator, well, let's see, we have 2 over 1, a and a squared. So here we need a factor of a squared. Here we need a factor of a, which is incorporated in the a squared, right? Because a squared is a times a, so we definitely have a factor of a already. And the 1 is just the identity, so we don't have to worry about anything unique there. So it looks like our common denominator for the numerator is going to be a squared. We want to rewrite each term so it has an a squared in its denominator. Here we need to multiply by a squared over a squared. Here we already have one factor of a, so we need just a second factor of a, so we're going to multiply by a over a. This already has the a squared, we don't need to do anything. Now when we combine these, we're going to have 2a squared plus 5a minus 3 divided by a squared. So now our numerator is one term, right? Because we have it all in one single fraction. We're going to do the same thing with the denominator. Our denominator is 2, which we're going to write as 2 over 1, minus 5 over a plus 2 over a squared. The common denominator here, well, it's actually the same denominators, right? We have 1a and a squared, so the common denominator will again be a squared. Here we need to multiply by a squared over a squared. Here we need to multiply by a over a, and here we don't need to multiply by anything. This makes our denominator become 2a squared minus 5a plus 2, all divided by a squared. Now that we have both the numerator and denominator as one single term, we can put them all back together. So we're going to go way up here. We have 2a squared plus 5a minus 3 over a squared, all divided by 2a squared minus 5a plus 2 over a squared. And if you notice here that the denominators match, right? The denominator of the numerator is a squared, and the denominator of the denominator is a squared. When the denominators match, you can cancel them out. If you don't remember to do that, that's fine, and I'm not going to take any shortcuts here, just so that way we can see it all laid out. So now that it's written like this, with one single term in the numerator and one single term in the denominator, we can write it using the division symbol. So we'll say 2a squared plus 5a minus 3 divided by a squared, division symbol, 2a squared minus 5a plus 2 divided by a squared. And now that we have it written like this, we can say, wait, there is a multiplication that's identical to this or equivalent to this. We can multiply by the reciprocal of the divisor, and that would give us 2a squared plus 5a minus 3 divided by a squared times a squared over 2a squared minus 5a plus 2. Okay, we're finally in a good spot. We like being right here. And now see how these cancel out? So that worked out really well. So when the denominators match, you can cancel them, and the numerator of the numerator will be a fraction over the numerator of the denominator. So those would just stay the same. This doesn't work quite as well if you can cancel the denominator, the numerators, but with the denominators, yeah, you can just cancel those out. Okay, now we want to see if the numerator has any more common factors with the denominator, and I think we need to factor our terms here. So now the numerator, we want to factor 2a squared plus 5a minus 3. The target product is going to be 2 times negative 3, negative 6, and the target sum is going to be that middle coefficient 5. So we're looking for two numbers that multiply to negative 6 and add up to 5. Well, two things that multiply to negative 6 and add up to 5 would be positive 6 and negative 1. So we're going to replace 5a with 6a and minus 1a. This would be 2a squared minus 1a plus 6a minus 3. And I always like putting that negative first if I have the choice. So that's why I opted for the minus a before the 6a. Now we have four terms. We can factor by grouping. The greatest common factor of the first two terms will be 2a. Sorry, what am I talking about? The greatest common factor of the two first terms will be a, leaving behind 2a minus 1. And the greatest common factor of the second two terms is 3, leaving behind 2a minus 1. And now these two terms have a common factor of 2a minus 1. See, this is scary stuff, so there's a thunderstorm going on at the same time. And we end up with 2a minus 1 times a plus 3. Okay, what about the denominator? What do we have there? In the denominator, 2a squared minus 5a plus 2. The target product is positive 4. The target sum is negative 5. Can you think of two numbers that multiply to positive 4 and add up to negative 5? That would be negative 4 and negative 1. So negative 4a and negative 1a is going to replace negative 5a. They're both negative, so I don't get to use my little shortcut this time. So we have 2a squared minus 4a minus 1a plus 2. And now I'm going to group the first two terms. I'm going to be really careful when I group those second two terms because we have to be really careful with that negative. And then the greatest common factor of the first two terms is 2a, leaving behind a minus 2. The second two terms have a greatest common factor of 1, but since the first term is negative, I'm going to factor out a minus 1. And what that's going to do is it's going to change the sign. So this negative becomes a positive, this positive becomes a negative. Now these two terms have a GCF of a minus 2. And we have a minus 2 times 2a minus 1. Okay, so now let's see what happens. We have 2a minus 1 in the numerator times a plus 3. And in the denominator, we have a minus 2 times 2a minus 1. Do we have any common factors? We do. 2a minus 1s will cancel, and our final simplified quotient will be a plus 3 over a minus 2. All right, so what did we do? First, we rewrote the numerator and denominator as single terms. Then we used the division property to first rewrite the complex fraction as just division of rational expressions, and then we were able to say, wait, we can rewrite this as multiplication by multiplying by the reciprocal. Once we did that, we started looking for common factors. We factored what was left of the numerator, we factored what was left of the denominator, looked for common factors again, and then wrote the pieces that stayed behind, or the factors that couldn't simplify away. All right, another example. In this one, again, we have a complex fraction in the numerator, and we have two terms in the numerator. So the numerator, we have x over 1 plus y over x. In this one, the common denominator will be, looks like, well, between 1 and x, it will be x. And this one already has that common denominator. Here we need a factor of x. So we're going to multiply by x over x. And our new numerator as one single term will be x squared plus y, and our denominator will be x. Here the denominator is two terms. We have y over x plus x. We're going to put it over 1. Wait a minute. This is sneaky, isn't it? I'm doing a lot of work and I don't need to. Do you see why I don't need to do all this work? Because we could use the commutative property and rewrite the denominator. This would be x plus y over x over, use that commutative property, flip those around, x plus y over x. Do you see what happened here? The numerator and the denominator are identical. What's any number divided by itself? This one equals 1. That's it. That's all we had to do for this one. That was nice. Moving on to our last example. I don't think we're going to be as lucky with this one. Nope, we have a little bit of work to do. The numerator, I see two terms. We want to rewrite first as one term. So we have 1 over 6 minus 1 over a. So it looks like we're going to need a factor of 6 and a factor of a. And here we need that factor of a, so we're going to multiply by a over a. Here we need that factor of 6. We're going to multiply by 6 over 6. Our newly single term numerator is going to be a minus 6 divided by 6a. In the denominator, what do we have? We have 1 over 36 minus 1 over a squared. The common denominator here, well, we need a factor of 36 and we need a factor of a squared. This first term is missing the a squared piece, and this term is missing the 36. So now they both have a denominator of 36a squared, and when we write this as one term, it's going to be a squared minus 36 over 36a squared. Okay, very good. Now we can rewrite this as one single fraction. So this will be, let's see, our numerator is a minus 6 divided by 6a all over a squared minus 36 over 36a squared. And a really common mistake I see a lot is people say, look, we have a's there, how fun is that? But those don't actually cancel because a is not actually a factor of the numerator, it's a piece of a factor, right? Factors, the only thing happening to factors are they're being multiplied to other factors, and a has something else going on, it's being subtracted. So a is not a factor of the numerator. Now we're ready to rewrite this using the division symbol. So we're going to say a minus 6 over 6a divided by a squared minus 36 over 36a squared. Once we have it written like this, we might use the fact that we could rewrite any division as multiplication and say, okay, we can rewrite this as a minus 6 over 6a times 36a squared over a squared minus 36. Now we want to see if we can factor anything. Let's see, a minus 6, nope, this is one single factor. Down here, a squared minus 36, what's that? What's that thing called? That's called difference of squares, and it factors into root minus root times root plus root. So we're going to replace that with its factored version, and now let's look for some common factors. Oh, here's one. We have a minus 6 factor. 6 and 36 are both divisible by 6. We would have 6 left there. When we divide it by 6, we would have a 1 left here. A squared and a are both divisible by a. If we factor out or divide by a, we'll be left with 1a there, and this one will go away. And what do we have left? In the numerator, we have 6a. In the denominator, we have a plus 6. And this would be our final answer. So complex fractions do require a lot of work, but each step in and of itself is not super scary. So I encourage you, take your time with these. Do it one step at a time. Don't think about the whole thing. Just focus on the one thing that you're doing, whether it be writing the numerator as a single term, writing the denominator as a single term, writing this as multiplication, or factoring. Don't overwhelm yourself. You can do this. I know you can. These have been examples of complex fractions. Thank you for stopping by.